Hello from Idaho. You'll just have to imagine that there's a lathe sitting on this cart. It's actually back ordered. But this is a Trinity 48-inch stainless steel box that I found on Facebook Marketplace. I have replaced the casters with solid legs and adjustable feet to give the lathe a nice base to sit on. Of course, the lathe will go there. There's a tool shelf. The white shelf is for measuring tools that are being used in the process of a job. The pine will be soft and will be forgiving. The top shelf really has nothing to do with the lathe. It's just so that I can use my space all the way to the ceiling. The sawhorses and power outlet have been moved since the last time I showed you my shop, so that this all fits. These are 24-inch LED strips, which are powered from my built-in outlet. So a switch and an outlet box, and then a 90-degree turn that gives me 6 outlets, which is more than enough for the lathe and lighting and whatnot. So the overhead lighting will be just about in line with the spindle of the lathe, so that my head won't cast a shadow. I have painted the front side of the LED with black paint to keep it from glaring, and it's doing a good job. And so I'm all ready to receive my lathe whenever it gets here. Now I will show you a little bit of the construction. Here's my plan for wiring for the lathe. This is going to be a switch, easily accessible from the front. And here is an outlet that will allow me to plug in the lathe and my overhead lights, and it'll all be switched so that I can easily turn things on and off. Okay, the lathe stand is all wired up now. I've got a 6 outlet 90-degree turn adapter plugged into the outlet box, and on this end we have switch. Off is the easiest to get to position, and then this is on, which makes my little night light, test light, work. And yes, I know it's red. I scrounged these parts up and painted them when I originally had a red toolbox on order. After that order was extended 10 weeks without notice, why I ended up finding this Trinity box on Facebook Marketplace, which is a better box anyway, and I ended up paying less, so maybe they did me a favor, I don't know. But anyway, the power outlet is red instead of black or white or whatever color would have went with silver, with stainless. But at any rate, it's done. The only real provide more power than I currently have knowledge of, just in case something changes. At any rate, this step is done. Lots more steps to go. And here is the result of about an hour on the metal cutting bandsaw, cutting my 5-inch channel up into 4 rigid feet for the lathe toolbox. There's an adjustable foot that goes in here. There'll be a nut welded on the top and the bottom of the channel iron, and then that way the foot can be adjusted to level the lathe. And then of course this end will get a hole here and a hole here that matches the bolt pattern in the bottom of the toolbox. So bead blast is next, then drill some holes, and we're getting closer. Normally I don't show drilling holes and whatnot, but drilling big holes, you know, up near 1/2 inch in thick material requires a good setup and helps to have a good drill press, one that can get down below 60 RPM. And even though you can, with a drill press, you can muscle a big bit down through the material, I'm inclined to drill pilot holes. And so, with the part in a vise, and then the whole thing clamped down, usually when a bit catches and makes the part go round and round and round, it's because the part wasn't held sufficiently enough. Usually it's because it wasn't held down, and the bit was able to, instead of take a few thousandths per revolution, it starts taking 100 thousandths per revolution, and it gets stuck. And so having the part held down is important to be safe. This is too slow for this drill bit. It doesn't hurt it. It just takes a while. I bought this drill press in 1992, and it's a 3/4 inch chuck with a 20 inch table. Okay. And it has served me well. So these holes are 27/64, which is a clearance hole for a 10mm bolt, which is what the casters are held onto the toolbox with. And they go up into rib nuts, which is a nice solid way to do a toolbox. Okay, now we're going to drill 27/64 in the same hole. That way I don't have to clamp more than once. And this is a good speed for big drill bits. And a good speed and a sharp drill make short work of a hole that's essentially 3/8 of an inch deep. I like to break the chips instead of let them get big, because the long chips get stuck in the hose of my vacuum, of my shop vac. So it's just a little self-preservation to make my life easier. Here is the setup for welding on the nuts. Just take a bolt that threads into the nut and then cut yourself a spacer out of a pop can, and that will make sure that the bolt is centered in the hole, and therefore the nut is centered over the hole. And then when you go to screw in your feet, they won't interfere, they won't slightly touch the hole. Here's my welding setup, clamped to remain flat, and then weld on the nut and weld the butt joint and let it cool until it's cool to the touch. At that point, the chances of warping are over. And then turn it over and weld the backside, and then grind the backside flat. Okay, this is the last step on the sturdy feet truck bed liner. Okay, it's about time to remove the casters from the toolbox and replace them with these feet brackets and the adjustable feet. It would be nice to be able to roll the lathe around, but given how hard it is to level, I'm sure that the first time I rolled it, it would be out of level, and then it would continue to be out of level for forever. So with the adjustable feet and the solid feet brackets, I should be able to maintain level once we get the lathe on there and all of the shelves and whatnot. I've got a Precision Machinist level. These are really nice casters. I'll save them for something else. Let's see. This one goes here. The rib nuts in the toolbox are really nice because you don't have to try to reach inside and grab a nut in a washer and whatnot. And these are good bolts. They've got a serrated head. Okay, 1 down, 3 to go. I'm not going to bore you with all of that, which is how you get all the angles and clearances and know where everything goes. Good clamping and tack welding is the key to a straight structure. So I've got a big 45-degree clamp, magnetic clamp, that ensures that this angle here is 45 degrees. I got two 22.5ers. And then this strap across here ensures that this plate is flat with that plate. And so I'm ready to tack weld. Okay, after everything is double and triple checked and measured, we're ready to tack the lower leg to the upper two pieces. Here is the final mock-up of the metal structure for the shelf system for my lathe cart. All the dimensions and angles and whatnot are correct, and I just need to I just need to finish weld it and then prepare it and finish it. Right now it's held on with some clamps. In real life it will be held on with 8 pop rivets at the top, 4 here and 4 on the back side, and then 8 pop rivets at the bottom, 4 here and 4 on the back side. Those are 3/16" pop rivets, so it'll be attached to the structure of the box very securely, and I shouldn't have to worry about putting weight on it. These holes are for a wooden shelf that will extend out here 9.5 inches. Not far enough to get in the way of the lathe, but it will give me a soft place to put micrometers and calipers and other measuring tools, since wood is very forgiving. The top is an 18 by 52 inch shelf. Okay, today we're making the middle shelf that will be a convenient place to set micrometers and calipers and other measuring equipment. It's made out of wood. The base is a 1 by 12 and the stiffener is a 1 by 4. It'll be glued and screwed together. I've already made a couple of screws. And as usual, I'm not going to show you the whole thing, but you get the idea of what I'm doing. There'll also be one by 4. Okay, it's a couple hours later now. I have finished the rough woodworking on the middle shelf, and it is clamped in place. It needs the corners rounded over, finish sanded, and of course some sort of finish. It's going to be handy to put tools on. It's made with a 1 by 12 and a 1 by 4. This is 1.25 inch oak baseboard molding, so there's a little lip here. But that ought to be a nice place to put micrometers and calipers and other measuring instruments while a job is in progress on the lathe. Getting ready to add the shelf stiffener. I've got the location of the shelf stiffener outlined in tape so that I can sand that portion and only that portion, and then glue it, and that way I won't mess up the finish on the rest of the bottom, even though nobody cares. Okay, the top shelf is ready to go on. Got my stiffener under there, and I've wired up a custom set of wiring so I can power both lamps from one cord. There's a switch here which I probably won't use, but who knows in the future. And then the wire will run alongside the structure and down to the outlet. So it's ready to go on. As usual, if you like or dislike my video, please select the appropriate button and let me know why. I really appreciate comments and I will answer every one. If you're new to my videos, please select the subscribe and the notification bell to get more videos like this.